Hello and welcome to this next video on mobile repairing. In this series, we are trying to understand how we can do jumper settings in different faults that are identified on a mobile PCB. In this video, we will spend our time trying to understand how we can detect a dead handset fault and how we can rectify it using the appropriate jumper setting. A dead handset is typically something which has no reaction. You switch it on, you will not see anything on the screen, and there is no feedback that you receive on the screen. The display device is usually off and the phone doesn't function at all. So in such cases, there could be multiple reasons why a set or a handset could be declared dead. The problems could start straight from the battery aspect of the mobile phone, which supplies power to the mobile phone, to several other components, including a display fault on the mobile handset. So it's important first to detect where the fault has happened before you even decide whether you want to do jumper setting or if any other repairing needs to be done. Many a times the components themselves could be dead, or they could have malfunctioned, or there could be a problem in the components inside. The IC may not be working properly. So in those cases, you may need to replace those components, and a jumper setting may not really solve the problem. So where does jumper setting help when you are repairing mobile phones? Jumper setting is typically best when you need to connect two different points on a mobile phone. There could be internal disturbances in the circuit of the mobile phone which are connecting these 2 points. And because of the internal disturbance or a breakage in the circuit, the power or data may not be traveling from one point to the other easily. And in those cases, we use jumper setting to try and connect those 2 points directly, thereby ensuring the correct transmission of power or data from one end to the other end. But in order to determine whether you need to do jumper setting or not, you must first check the basic components. For example, if you are detecting a ringer problem, you may need to first check the ringer using methods that we have spoken about before. If you are checking a battery connector, you may need to first verify whether the battery connector is working properly or not before you decide to make any changes or test any connections on the mobile phones. Now in this mobile phone, the first aspect that we are going to be checking is the connectivity between the battery connector and two other important components that transmit power to the rest of the circuit of the mobile phone. Now, in order to test out the connectivity in the mobile phone PCB, you need to use the multimeter, place it in the beep or continuity testing mode, check whether the two probes are connected and you can hear the beep. And once you hear the beep, you think that the multimeter is perfectly all right. Let's go ahead and test the connectivity on the board. Now, typically, we are going to be starting off with checking the battery connector. You need to identify the positive and the negative points on a battery. And we already know that the negative point on the battery is what is the background connection. As you see, the yellow color line is the negative line of the battery that is traveling all through the mobile PCB. So let's keep the probes on one end and connect it. And now we can hear the beep. This basically means that the battery connector negative point is here. So this is the negative point which is traveling all through the mobile phone, and when you place the probes on the yellow part and on this particular connector, you will be able to hear a beep. Now that we have identified the positive and negative points of the battery connector, we need to connect it to different components to see if there is power connectivity which is flowing through or to the rest of the components. So we are going to first test with two components. One is an MFD condenser and the second one is an R22 resistor. These are two power related components that are placed on the mobile phone PCB. So, first of all, let us try and test out the MFT condenser connecting point. So, we place one probe on the positive end of the battery connector and the other on the positive end of the MFD condenser. So, when you place it there, we are not able to get any beep at this particular point. If there is any connectivity between these two, you will hear a beep sound very clearly, signifying that the connectivity between these 2 points is intact. On the other end, we will also try and test it if the connection between the battery connector and another component is intact or not. So, let us place it on the positive end and let us place this on the R22 resistor to see if we can hear a beep. So, one end on the positive end of battery connector, other end on resistance, and we can hear we cannot hear the beep here as well. So, which basically means that the connectivity between these points are broken somewhere in between on the PCB, and we need to use the jumper settings to re-establish connection between the battery's positive point and the MFD condenser as well as the R22 resistor on the mobile PCB. Now, in this case, because there is no power supply to the rest of the components, the mobile is completely dead and it is non-functional. So, we will try and re-establish connecting points between these positions and then ensure that the connectivity is intact after that. To do this, we take the jumper wire, as mentioned in the earlier videos. We need to remove the insulation in the tip of the jumper wire. So, we use the micro soldering iron and try and remove the insulation part in these wires. So, let us try and slowly take off the insulation part from the tip of the jumper wire. You may also want to use a little bit of the flux to give it that finishing touch. While you are doing this, please be very gentle on it. If you press it too much, it can result in the wire getting disconnected. So, you hold it lightly and try and slowly remove the insulation from the tip of the jumper wire. Use a little bit of paste in the front and try and take off all the insulation from the tip. Once the insulation is removed, you can then now connect the jumper wire to the 2 points that we have identified. The first point of the jumper wire will be connected to the positive point of the battery. Now, the battery connector's positive end is on one side, and on the back side is where you will solder the jumper wire. Now, we are soldering it at the back side of the connector, because in the front you will be inserting the battery, and when you insert the battery, this wire may come off and it can be a disturbance while you are connecting the battery. Hence, we solder it at the back side of the battery connector, and then on the other end we connect the jumper wire to the positive point of the MFD. Now, before you connect it, please cut the wire out using a cutter depending on how much length is required. Do not cut it exactly for the distance that you require, keep it a little loose so that it can be bent and kept in its position properly. Once you have cut it to the required length, you can clean out the tip again. You need to remove the insulation in the tip so that it can be connected to the positive point of the MFD condenser. So, using your soldering iron, you can slowly try and clean out or remove the insulation in the front, and then place the end onto the positive point of the MFD condenser. Let us take a little bit of soldering wire, melt it out, place the wire at the positive point of the MFD and solder it at its position there. Be very careful while you are doing it, ensuring that the wire does not come off from its earlier soldering point. Also ensure that you solder it lightly so as to not to disturb the soldering that is already present in the MFD condenser. So, we have now soldered it appropriately in its position and have re-established connectivity between the positive point of the battery connector and to the positive point of the MFD condenser. So, the MFD is basically an electrolytic condenser which is used in the mobile PCB. Let us now try and move on and check the other aspect and see how we can connect the positive point of the battery to the R22 resistor placed on the mobile PCB. Now, many times you may need to try doing multiple jumper settings to check whether the power is being transmitted to different components correctly. Let us try and solder one end of the jumper wire to the resistance or the R22 resistor and connect the other end to the positive point of the battery connector. Now, you may want to continue testing this using a circuit diagram. Circuit diagrams very clearly demonstrate how the power supply happens within a PCB. And once you are aware of how power supply happens, you can use continuity testing to keep checking smaller segments on the mobile PCB and find out where the disconnection is. And this disconnection could have happened in the internal PCB. So, in those cases, you will need to use a jumper wire to be able to connect 2 points where the connectivity is not present due to some breakage in the PCB. Now, we have soldered this part as well onto the positive point of the battery connector, and you can very clearly see that the wires are intact in their position now. So, in this video, you saw how you can connect the jumper wire to different components within the PCB to ensure that power is transmitted onto different components. Most often than not, when a mobile phone is dead, this could be one of the reasons, or this could be one of the ways how you can revive a dead handset. We do hope you would have understood how to do jumper setting for a dead mobile handset. We hope that you will continue learning going forward. Thank you very much.